Now we will see the exercise 3.4 of squares and square roots. Now this method of squares and square root is used, is called as long division method. Now this is a very important kind of a method, uh, slightly difficult to understand. So be very attentive to understand what exactly needs to be done for this particular method. Now, in this case, what we need to do. So in here the main thing is that you can also take out the main advantage of using the long division method is that you can also take out the square roots of numbers which are not perfect squares. So even if it is not a perfect square, you can find out the square root which will be in decimal points. So you may have up to 2 decimal points, 3 decimal points, 4 decimal points. So you will be getting an approximate value of the square root in decimal points by this method, which you cannot get it by prime factorization. In prime factorization, it has to be a perfect square. Only then you can go for prime factorization. If it is not a perfect square, you cannot find out the square root of that number by prime factorization. So here, this particular method is mainly for those numbers which are not perfect squares. So the method goes this way, that you need to first write the number. So let's take a particular number as, we'll take it as 288369. Now this particular number 288369, I want to find out the square root of this. So for this, first of all is I am going to write it in this way, that there will be a framework like this, wherein I will write this number 288369. Then starting from the right hand side, I am going to make pairs of the numbers. So from here this is one pair, this is second pair, and this is the third pair. Okay, so we are going to first divide the numbers in pairs. Like for example, if the number would have been 543, then it will be 2 and 1. So it will be, this is a pair and this is a single number. If the number is 5743, it will be like this, 2 pairs. If the number is 5714391, then it will be these two numbers, this two numbers, this two number, and this will remain alone. So in this way you are going to make pairs. Now the same thing for pairing, if the numbers are in decimal points, like for example the number is 5.4314, then one side from the decimal point you are going to make right hand side, towards the right hand side, the pair. So it will be like this and like this, and here it will be just this way. Like for example, if it is 252.457, then it will be this two and this as one pair, and this as single number. Now because it's single, you can always add a 0 and make it a double number. Similarly, if it is only 5.2, you can always make it, and you want to have the square root, then you can have it as a single number and you can make this as 20. Or if you want more decimal points, then another thing. Now this will come to know as we are doing the sums of this kind. So but basic thing is that you need to first divide the numbers in pairs. You have to make pairs of the numbers, and that pairs will start from the right hand side towards the left. So you are going to ulta way, and you are going to make two numbers ka pairs. Agar last में एक number रह गया, not a problem. You have to keep it single number only. Similarly, if a decimal के दूसरे side पे, तो on the other side of decimal you take right from the first number and two ka pairs, and then you are going to add it in that particular manner. So this is the first step, that you are making pairs. The next thing is you are going to identify, like now we have the first over here, the number first pair is 28. So firstly we will try to find out that which is the nearest square number to 28. So I know that 5 5s is 25, whereas 6 6s is 36. So square of 5, 25 is the lowest before this. Okay, so accordingly I'll write over here 5. I'll keep some space over here because there are numbers going to come over here, so I'll keep some space over here. I'll put a 5 over here, and you know that 5 5s are 25. You put this 25, then subtract it, get 3 over here, and bring 2, this pair down. So it will be coming over here as 3 8 3. Now comes the main point again. This number, whatever I taken, I will add the same number over here and get over here a remainder as 10. So 5 plus 5, 10. So 5 into 5, 25, and here 5 plus 5, 10. This is what is the first step. Okay. Now we will see and add one more digit over here. I am going to put one more digit over here such that the multiplication of that digit with this whole thing is less than 383, just less than 383. Like for example, over here, if I take the number to be as 3, so what will happen? It is 103 into 3. So whatever number I am taking over here, I am taking the same digit and multiplying the whole number with the same number. Okay, so if I have taken 3, I'll take 103 into 3. So if I multiply, it gets 3 3s are 9, 0 and 3 0 9. Let's see if I would have taken 4, then what would have happened? So 104 into 4. So if I taken 4, then I multiply by 4. If I take 5, then I multiply by 5. If I take 6, multiply by 6. Okay, so accordingly, now 4 4s are 16 and 4 1 1 and 4 1 4. So you can see that this number is less than this and this number is greater. So I cannot take this number, I have to take this number. Accordingly, I'll have to take 103 into 3, that gives me 309. I'll subtract it to get over here as 4 and this becomes 7, so 74. Okay, and then I bring this pair down to make it 7469. Here the same way as what I did over here, 3. So I'll add 3 over here and now the number becomes 106. Whenever you reach a stage where you have the numbers over here and numbers over here, you will find that this number will always be the double of this. So 53 ka double is 106. You can always cross check whether you are going in the right manner or not. So if this is 53 and this is 106, means up till now we have done it correctly. Now let's see the next thing. So again, I'll take one more digit over here. I'll take one more digit over here. So which is the digit possible? I'll have to find out over here. Now because this is 1 and this is 7, so I'll try 7 first. So I have over here 1067 into 7. 7 7s are 49, 7 6 are 42, plus 4 is 46, and 4 and 7. You can see that we got exactly the same number as what we require over here. So we get over here as 7. You put the 7 over here. So you write 7 4 6 9. You subtract to give 0 here. Here you will say plus 7 as we did earlier. So this is 14 and then 7 0 1. So you can see that since I get 0 here, it means that this number is a perfect square and the square root of this thing is 537. So this is the answer. Are we clear with this? So whenever you have a number for which we need to find out the square root, and this method is the long division method. Okay, so in this long division method, as you see, we are doing step by step, and here the divisor is also keeping on changing. The difference between the normal division and this division is that my divisor keeps on changing as I keep on dividing. Okay, plus I am not taking out only one down but two numbers down. That's why we made it in pairs. Okay, let me give you one more example so that it is much more clearer to you how to do this thing. Okay, we'll take one more example. Let the example be root of 106,929. Okay, I want to find out the square root of this. So as I said, I will first write the number 106,929. I'll make pairs over here. So these are my required pairs. Now, what is the number? Which number, the square of which number is near 10? So we know 1 ka 1, 2 ka 4, 3 ka 9, 4 ka 16. So 3 is 9. So that is why 3 3s are 9, remainder 1. You bring this down to get this 169. Here plus 3. So this gives me 6. Understood? 3 3s are 9. Whatever was the remainder, we got the balance downwards, and accordingly 3 plus 3 is 6. Now I need to put one number over here. So because this is 6 and this is 1, and this, so we cannot divide, so it's 16 and 6. If I try to divide in 16 and 6, what is the possibility? 3 is the possibility, because 6 3s are 18. So I can try 3 or I can try something else. So first let us try 3. So 63 into 3, 3 3s are 9 and 6 3s are 18. So 189, but this is 169. So I cannot use this. I need to take the next one. So it will be previous one. So 62 into 2. So 2 2s are 4 and 2 6s are 12. So it is 2s are 2 here. That is 124. We subtracted to get as 5, 4, and this goes down as 29. So this 62 plus 2 gives me 64. Now again the same thing. This is 6, this is 45. So I can try with 7, because 7 6 are. So I have taken these two numbers. I have taken these two numbers and here the first number. Try to divide them. If the division, whatever is going to get me, could be the digit which can be placed here. So we'll try that thing. We'll try this as 647 into 7. 7 7s are 49. 7 for 28 plus 4 is 32. 42 plus is 45. You can see that we are getting exactly the same number. So accordingly, we have over here as 647. This is 7. This is 4 5 2 9. Subtraction gives me 0. This is plus 7. Give me 4 5 and 6. This is, now I can always check out again that 327 ka double is 654. So I am got correct thing, and accordingly my answer is 327. So that is how you do the long division method in case of big numbers. So let us now take up the sums from the exercise. Okay, we'll take the sums from the exercise. The first one. So exercise 3.4, first ka first is number 2401. So you need to find out the square root of 2401. It's the same way. We put these lines. Put over here 2401. This is the two pairs. 01 and 24 are the two pairs. 24 se nearest square number is 25, but 25 is greater than 24, so we have to take one lesser, so it will be 16. So it is 4 4s are 16. This gives me on subtraction as 801. Here plus 4, so we get over here 8. Now since this is 8 and this is also 8, so I can try this one, that I can see that this is 8 and this is 80, so it would be 10. So I cannot take 10, so I will try to take as 9. So it is 8, 9 into 9. So it will be 9 9s are 81 and 972, so that is 80. So we get exactly the same number. So it is 9, 9 and over here 801, subtract and give 1 plus 9. This gives me 98. So 98 ka is 49 and 98. We know 49 ka double is 98. So we are correct. Hence the answer is 49. Are we clear? Okay, let's see the next sum. Sum number 3, that is 106929. Oh, we just did that thing in the example. So I'll do one thing, I'll do the second sum instead, or I'll do the fourth sum instead. So I'll take the fourth sum, that is 167281. Okay, 167281. So that gives me over here like this, 167281 pairs like this. So 16, we know that it is a square itself, so 4 4s are 16, so 16, you remain 0 remains here, this is 72. Now this is plus 4 to giving me 8 here. Now I can see over here this is 8 whereas this is only 7. So definitely even if I take 81, so even if I take 81 into 1, it will be still 81, which is not going to be the number less than 72. So what I'll need to do, I'll need to take 0. So I'll take over here 0, put a 0 here, put 0 here, that's why it will be 72, and this 81 comes down, it will be 81. I'll add 0 to this, hence the number over here becomes 80. Got it? 40 ka double 80. Here 7281 is the number. Now I am going to check 872. I know 872 is 9s. So okay, 8 9s are 72. So I'll try that with 809 into 9. 9 9s are 81. 8 here and 7 2. It's exactly the same what I require. So I'll put a 9 here. 9 here plus 9 here, it will be minus 7281, give me 0 here, and this will be 818. So accordingly 818 is half of double of 409. So answer is, so square root of 167281 is 409. Are we clear with this? Okay, we see the next question. Question number 3. Question number 5, sorry. Question number 5 is 53824. Okay, we want to find out the square root of 53824. So we see over here as first thing the numbers is like this. It's 53824. Taking pairs, you will find that 5 is remaining alone. So what is the number nearest square number to 5 is 4. So it is 2 2s are 4. So 2 2s are 4. So remainder will be 1. 3 8 comes down. Now it is plus 2. So this becomes 4. So now I have got over here 4 and this is 138. So first two numbers here and first number over here. First two numbers is 13. Here it is 4. So what should be the division of this thing? So 13 divided by 4 is 3. So it will be trying this way. So it is 43 into 3. 3 3s are 9. So 129. Okay, it's easier to get it this way. You can try also 4. You can try 4, but you'll find that 4 will be greater than this. But you can see this. 44 into 4. 4 4s are 16. 4 4s are 16, 17. So it is 176. So not possible. So this is the correct thing. So 3, 3, this is 129. Accordingly, this will be 9 and this will be 2, 4. So this is plus 3, gave me 46. Okay. Now, your first number 4, your first number 9. Okay, because this is, you can see the digits are, so here it is 0, 9. That's why it is 9. So it is 46 is already there, so it will be 462 into 2. It will be 2 to the 4, then this is 12 and this is 9. So it is exactly 924 what we require. So it is 2 plus 2, that is 464, here 2 and here it will be minus 924, gave me the answer 0. Accordingly, the answer of root 53824 is 232. Is it clear? Have you understood this properly? So this was the first part of the exercise 3.4. which was to find out the square root by long division method. Okay. Now we see the next part of the exercise. Okay, the next one is find the square root of following decimal numbers by division method. So now we are going to have decimal numbers. So the first one is given as, so okay, second one over here, first is root of 51.84. Okay, so we are going to take the same way. We are taking the number like this as 51.84. So pair over here like this and like this, because decimal ke baad mein pairs, decimal ke pehle pairs. So accordingly, this is one pair, this is another pair. 51, we know the nearest square number to 51, less than 51 will be 7 7s are 49. So we get over here 7 7s are 49. Remainder becomes 2 and this comes down as 84. Now because of the decimal point over here, I will put a decimal point over here also. So plus 7, this is going to be 7 plus 7, 14. Now here the number is 1, here the number is 2. So we can try with 2. So it will be 1, 4, 2 into 2. That will be 2, 4, 80, 284. So this is the same as what I require. So I'll put a 2 here, 2 here, 284 here. Here becomes 0. This is plus 2 to give me 144. And the number over here is 7.2. Therefore, the answer is 7.2. Easy? You need practice over here. Otherwise, it's very easy. So if you don't practice, then you cannot get this thing. So let's see. Okay, I'll do something bigger one. So I'll take the number, the second ka fourth one. I'm taking the second and third to be your homework. You can try it out and let me know if you have any doubts. So the number is 5.774409. So let's take the number properly. Okay, I'll need some more space. So I'll put it here. Okay, and here it is 5.774409. This is single because before decimal points only 1. This 2, and this 2. 5. The nearest square number to 5 is 4. That's why we take it as 2. 2s are 4. We get the remainder as 1. You put this down, so it is 77. Because of decimal point, you put a decimal point here. Plus 2, this becomes 4. This is 4. The first two numbers over here is 17. So 4 4s are 16. So I can try that thing. So I'll try over here as, I'll put the riff work here. It is 44 into 4 is 4 4s are 16. 4 4s are 16, 176. What I require is less than 177. So it's perfect. So it is 4 4 176 over here minus, that will be 1. Bring it down over here to make it 144. This is plus 4 to make it 48. 24, 48, so everything is perfectly right now. Now 4 over here, but here the 3 digits, so it's only 0, 1. Even if I put 1 over here, it will be 481. So again, it will be not possible to even take 1 over there. Hence, I will need to take 0. So when I take 0, I need to make a 0 over here. This will give me 0 here, giving rise to 141, and then 09 coming here. And here, sorry, 144 and 09 coming here. This will be plus 0 to give me 480. I need one more decimal now. So this is 4 and this is 14. So 3 times can be tried. So it will be 4803 into 3. 3 3s are 9, 0, 24, 12, 14. So exactly 14409. So it is 3 plus 3. Answer is 4806. Here it is 3, give me minus 14409 Answer 0. So that's why the final answer, that root of this is equals to 2.403. This is how we find out the decimal points ka square roots. So this is about the second part of the chapter, second question of the chapter. Okay, next in the next video.